proportional to the square of the distance between them. Newton further theorized that the force of gravity was proportional to the mass of each of the two bodies. If m1 and m2 are two masses, and r is the distance between them, then, Newton theorized, the force between them would be in the form of this equation, his universal law of gravitation. Newton discovered a fundamental relationship between mass and the force of gravity. Force is a vector quantity. The relationship here shows only magnitude. Since gravity tends to pull objects directly toward one another, the direction of the gravitational force between any two bodies is along the lines that join them. We signify the direction from one mass to the other by using the unit vector r, pointing like this. The unit vector r has a magnitude of 1. It's the vector r divided by the magnitude of r. It's signified by r with a hat on it. If all we want to do is represent the direction, we do that with the unit vector r. The force experienced by mass 2 because of mass 1 goes in this direction. The force on m2 being attractive is in the direction opposite to r. Therefore, the vector equation for the universal law of gravity is F equals minus g times m1 m2 over r squared times the unit vector r. The force between the two masses is as if they were 2-point masses, which are idealized objects having all their mass centered at one point. Let's consider the force that m1 exerts on m2. m1 is the distance of r12 away from m2. The force that m1 exerts on m2 is F12, n equals minus gm1 m2 over r12 squared. Let's consider this the other way around. The force F21 is exerted by m2 on m1 and goes in this direction. F21 equals minus gm1 m2